All right, welcome back. Today we're going to finish up Jdbc. Last week we were looking about how to pull data from your database, and today we're going to add the last piece, which is pushing data to your database or persisting data to your database. So remember, we are live on Piazza. If you have any questions, go ahead and post there. Otherwise, the same basic process, you can use this. So again, you may need to load your Jdbc driver if you're using very, very old Java. Otherwise, you create your connection, you create and prepare your query, and you potentially process your results. So what I'm going to do here is I'm going to come over here, and I've already changed the director and the film class slightly. For example, I've added a constructor here that doesn't require you to provide the director ID because we don't know that when we're initially inserting records. But I still want to be able to create a director with a first name and last name. So there's a default value of, actually I'm going to change this to null, because what I've done here is, and I'll need to change this here as integer, right? What I've done here is I've changed the director ID to null because you could, even though in the database you'll never have a primary key that's null, you could still have an object where you haven't inserted it or persisted it to the database yet. So we'll allow that to be nullable in our class. Likewise, over here with the film ID, I'll go ahead and change that to an integer, and the default value here will end up being null. Right? So the film, I've got a constructor here that takes the title and an object that represents the director. And I've also got no, this is the load data from last time. This is a save data class that I'm going to now work on. So we've got Dennis Villanueva, who is the director of the new Dune film coming out in October. Plug. I have no, other than being a fan, I have no skin in the game on that one. But let's go ahead and insert this record. So what I'm going to do is I'm going to start out by defining a public static void insert film. All right, and it takes a film object, right? Of course, you could provide the title and the director's names, first name, last name, etc., everything that you would need to insert this record, but then that would kind of defeat the purpose of having an object-oriented programming language. We're going to insert this film object. Okay. So again, same basic process. I'm not going to load the Jdbc driver because I'm using a sensible updated Java. But I will create a connection to my database using my password, my username, etc. And for that, I'm just going to go back to load data and steal that piece of code right there, right? Making your connection, okay? And again, if I were doing this as a full project, I would probably put this into a factory method so that I didn't have to do this over and over again or store my password in multiple places. Just store it once and that's it, okay? So I've made my connection. I need to create and prepare my query. Okay. Oops. Go back over here to save data. All right. So here's going to be my query. Insert. I could call this insert film record or something like that. I'll just call it query here. Insert into film. Capital IFLM. Right. Again, let's go back over here to the MySQL workbench and let's debug by using MySQL workbench. Let's debug our SQL before we cut and paste it into our Java code here. So describe film here. What do we need for a film again? Oops, there we go. All right. We don't need the film ID because that's automatically created for us. We do need the title because it's not nullable. Looks like I did insert the EIDR and it's not nullable. Okay. But otherwise, I also need the director ID here, right? So for the EIDR here, default of null, it's not nullable though, and it has to be unique. So we're going to have to put something in there for it, and I'll just put in some garbage values, okay? Because that's not going to be part of this demonstration over here. So what does it look like? Insert into film, right? Film, title, EIDR, and director ID, right? Values. And then remember what we did. I mean, if I were to actually insert this in MySQL Workbench, of course, I would hard code these string values. But that's not how it works in my Jdbc. I need to prepare my statement. So I need placeholders here. And the placeholders are simply going to be 3 question marks there. Right? Remember that those will eventually be changed so that, that we fill in those values, but we use a prepared statement to do so. Okay? That's everything that we need. Another note here, I think I mentioned it last time, but just in case I didn't. Remember that over here you have nice color-coded markup on all of your keywords. Over here you don't. So you might have an argument for using the old school way of putting everything as caps, right? Just to offset it. I don't like doing that still because, you know, I mean, it's not that off-putting. And there are, I'm sure that there are plugins that you can get for Eclipse where you can mark up this kind of syntax within strings, basically. Okay. All right, there's my query. Now I need to prepare it. So prepared statement PS is equal to con.prepare statement. Prepare statement. There we go. And I'm going to go ahead and give it that query. I need to, of course, import this. Remember that everything that you'll be using is in the java.sql library, right? And prepare statement. Oh, yep. Remember also what else? Everything throws an SQL exception, a checked exception. Right? So I'll go ahead and initialize it up here, and then put this into the try catch. Catch SQL exception E, and how do I deal with this? I catch and release, just like any good angler out there, right? Throw a new runtime exception, wrapping up E and letting it be fatal, okay? Again, there's really no way that you can recover from a missing password or no network, etc. Question online, what's the difference between an int and integer again? If it's an int, it cannot be null, right? So the default value here would have ended up being 0. But here, you can have try-valued logic, where it can be null, or it can be 0 or 1 or -1, whatever, right? That's the difference. If you're allowing things to be null in your Java code, basically, then you need to use the big I integer, okay? All right, let's see, where were we? Go back over here to save data, okay? So I've prepared my statement. Let me go ahead and clean that up a little bit. And now I need to set these 3 values right here, right? ps.set, the first one is a string, so string. And the title here, of course, if I hard-coded it, would be Dune, right? And remember, it's indexed by 1, so Dune, right, like this. Except that I don't want to hard-code this. Remember, I'm writing this function that I've already been given a film object. So instead of hard-coding that, I'll go ahead and ask, well, film, what's your title? I'll go ahead and set that as a string. ps.setString 2. Now, this is the EIDR that has to be unique. So I'm just going to hard-code this value to foo, 42. Right? And if we run this multiple times, of course, we're going to get into trouble because once that's used as an EIDR, then that's it. It has to be unique, and so we'll have to come back and change this. But otherwise, the third one here is a director ID. Right? ps.set integer, 3, and then d.get, or f.get the director, dot get director ID. Right? There we go. Now what I'll do is I'll go ahead and execute that update. Execute update. There we go. So that's going to be a little bit different from what we did in a load data over here. Remember load data, we prepared the statement, we set it, and then we executed the query. Execution of query results in a result set. It's only for select statements. Execute update is for update statements where you insert, you update, or you delete. Right? So unfortunately, there's a little bit of a misnomer there because all 3 of those operations have the same function name, execute update. Even though you would use the same thing for delete as well as insert, which is what I'm doing right here. Okay? All right, great. Once I'm done, what do I need to do? PS dot. Or what do I do with my prepared statement once I'm done? I've executed it, it's done. Close. PS dot close. And once I've executed my prepared statement, the connection that it was based on, is going to also be closed. There. That looks pretty good. So let's go ahead and try and call our save data dot save dot, or sorry, dot insert film. There we go. F. Are you highly confident that it will work? Let's find out. Uh-oh. What happened? Null pointer exception on save data line 29. What was null? The director wasn't null. In fact, let's go ahead and say, oh no. In newer versions of Java, it'll actually tell you what was null in that execution. It could be that F was null, but that's not the case because we can get its title. It could be the director was null, but it's not the case because I built the director down here. So what was null? The director ID, right? So what's the problem? Can I insert a film record with no director ID? It's not nullable, right? So what do I need to do here? In order for a film record to exist, which is a child of the director table, what do I need to do first? I need to make sure that that director exists. Let's go ahead and select everything from director, right? And I don't see him in there. There's no Dennis Villanueva there. Just a Quentin, JJ, and David, right? So insert it here in MySQL Workbench, and then use that, that value over here in my code. Well, as a one-off solution, maybe, but that's not a solution that's going to work forever. So what do I need to do? I need to make sure that this director is already in the database. So let's go ahead and put this on the back burner for now. And let's go ahead and create another function, public static void insert director, right? Director D. But before I go any further here, let's think about this. What if I want to insert a film by Quentin Tarantino, I don't know, Pulp Fiction, where Quentin Tarantino is already in the database? Should I go about inserting a duplicate record of Quentin Tarantino? No. So let me rename this function to something a little bit more of what I want, right? Get or insert director, right? That seems like it would be really useful, because if the director already exists, okay, here you go. And also, here's the first name, the last name, and the director ID. And you can use that director ID to insert films. It doesn't exist? Don't worry. I'll go ahead and create it for you. I'll insert that record, and here you go. Here's the object that was just created by getting it out of the database. Okay? So get or insert director. How can I determine if it's already in there? One, if the director already exists, get it, right? Well, over here in the load data class, I have a get director by ID. Is that going to work though? If the director doesn't already, if I don't have a director ID, I just have a first name and a last name. Does this director exist? Does Dennis Villanueva exist? Probably not, because I'm giving you the ID and then you're giving me the rest of the data. What I want is, I want to give you the first name and the last name, and then I want you to say, okay, here you go, here's that director, with all the other aspects of them filled. Right? So go back and destroy this, get rid of this because it's not really what I want. No. Right? If you want, I still want that because it seems useful, right? Get a director by ID. So let's go ahead and make another one, public static director, get director by what? Name. Right? And for this one, I'll go ahead and take a director object. Director D. Okay. Cut and paste all this stuff here. And in fact, I'm going to cut and paste the entire thing here. Right? But my query will be different. Right? So select, I want to know what the last name, first name is. I have the last name and the first name. I want to know what the director ID is. So let's go ahead and select director ID from director where the first name is equal to something and the last name is equal to something. Now I've got two parameters here that I have to set. So instead of setting the first parameter here to an integer, I'll set that to a string and d.get first name. Right? And the second one, d.get last name. Right? Then what I can do is I can execute this. I no longer need this stuff here, right? Because I've already got the first name and the last name that you gave me. All right. So if the director with that first name Dennis and the last name Villanueva exists in my database already, then I can go ahead and just reuse these values, right? D dot first name, D dot last name, and then I will get the director ID. But that's actually what I need, right? I need rs.get int. The column number will be, the column index will be, or director ID. There we go. That's what I want. And then of course I need to store that off into this variable, int director ID equals. Right? Now that's assuming that the director exists because we have this if statement up here. If results, remember the result step is pointing before the actual results. rs.next will point to the first record, if there is a first record. If there are no records at all, then rs.next immediately advances past this empty set and returns false. So if I've got one result here, then I know that I can build this director and return it. Otherwise, I'll return null, right? And maybe log a system error here, okay? All right, and then return this. And it's not compiling. What are you complaining about? Oh, and then director with, and then I'll need to change my error message here. Name equal to d dot get last name, oops, comma, and then the first name plus d dot get first name. There. And now you should be happy, except that you aren't for what? Oh, I've got two D's here. So I'll call this one result. Actually, yeah, I'll call this one result. There we go. I could reuse the value down here, but I'll go ahead and use result instead. And it's already null, and I don't need that line there, but I'll go ahead and return the result right here. Okay? Now, over in save data, if the director already exists, get it. So I can now use that function, director D, or actually, existing director is equal to load data dot get director by name, and then I'll pass in that full object there. Okay. Now, if you created that object and the first name was null or the last name was null or some combination of that, then you'd probably want to redesign that a little bit more, right? Because then there is a way to set null using Jdbc. Let me just show you really quick over here. In the load data, the prepared statement, instead of setting a string and then letting it be null, ps.set null, right? And then whatever SQL type this is. I'm not going to get into that, but there is a function that you can set null to. Okay. All right. So this is the existing director. If the existing director is null, equals null, then I know that it does not exist. Insert the new record. Okay. Else, I do know that it exists. So what can I do immediately? I can return it. In fact, I typed this out as void. Let's go ahead and change this. Get or insert director. You give me a non-persisted, a non-saved object, just an object that exists in Java, but not in your SQL database. I am going to take that and load something up that's equivalent to that in the database, giving you a new Java object, or I'm going to say, oh, it doesn't exist. I'll go ahead and insert it for you. Right? But if it already exists, then what can I do? Return the existing director. Okay? If it does not exist, I need to insert that new record. And this is going to be, yet again, a copy pasta of something like this. Okay? There's my credentials. Insert not into film, insert into director. What values do I need here now? First name, last name, values, and then there are only 3. If you have two columns specified here and you end up with fewer parameters or more parameters, there will be an SQL exception. Right? So make sure that they match and the order matters. So the first name here is going to be d.get first name. The second one is going to be d.get last name. And we don't need a third. Execute update. Okay. And then close it. Otherwise, return the existing director. Right? There's still a problem here, right? And in fact, it's not even compiling because this method must return a result of type director. I'm doing that in this case. If the director already exists, I give them the existing director. Otherwise, if it doesn't, if it's null, then I insert the record, execute that update, but what do I need to end up returning here? Return ... That's not what I wanted, but what do I return? Well, if it didn't exist before, right, because that was null, if I call this again, then it should exist, right? As long as I was able to get to this point. So I could return load data.get director by name. Right? That's one way of doing it. Right? Another way of doing it would be to that record that I just inserted. Right? So this is option A. It's not ideal because that means that you're making yet another connection to your database and going over the wire yet again. And in fact, you've made like 3 connections at this point and then destroyed those 3 connections. So what I want to do, I want to do this in the same connection up here, right? So I'm going to ask the question, what is the director ID, the primary key value of the record I just inserted? Right? If I have that, then certainly I can create a new object and return it to you, right? Because what I can do is I can create a director, or what is the result? I'm going to put that up here. Director result equals null. There we go. So that it's scoped to the actual method. And then result is equal to new director, right? Director ID, the first name, d.get first name, d.get last name. Those are just the same values that I already just inserted. The only value that's missing here is this director ID. And that would be the answer to my question. What is the director ID of the primary key value of the record that I just inserted? Right? Now over here, if I inserted a record directly, right, then I would have to make another select statement to get it out. Jdbc has a nice little way of doing this, though. When you do insert statements, what you can do is you can prepare your statement a little bit differently. So instead of this, what I'm going to do is I'm going to, PS equals con.prepared statement query, and then statement, I'm going to have to bring this in, java.sql, there we go. Return generated keys, right? So what this does is this sets the prepared statement up to not only insert data, but it's going to keep track of the IDs that were just inserted so that it can return them back to you. Right? If you don't have, that's not the default. If you don't have this configuration here, then it will not be able to return the generated keys here, okay? All right, after I've executed the update, I can, well, here, I'll do it below the question here. A, get the generated, actually, no, I'm going to label this as B, right? Because this is really A. A dot configure your prepared statement to return the generated keys. Right? Then B, get the generated keys. Right? And we're only expecting 1 here. So result set rs is equal to, or I'm actually going to call these what it is, keys, right? Is equal to ps dot get generated keys. Right? Simple. It's as simple as that. Let me bring this in from SQL. There we go. And now I need to get the get the value of the first record. The value being the key generated, right? So C, it's going to be int director ID is equal to, now this is a result set. So what we need to remember that the result set, if there's one record, the result set is initially pointing before that record. So we have to see, was it, because an insert record can fail, right? It could result in a MySQL exception or something. And then in that case, rs.next would return a null if you were still active with the program. So we need to advance it to the next, advance the result set, then get the result, right? So keys dot next. Now, if we were only expecting one value, that's what we would do. And then director ID would be rs.get and, keys.get, keys.get. And I'm just getting the first one. I'm only expecting one, right? If I were inserting multiple records, say I inserted 5 records, then the result set could potentially be of size 5, in which case I would need to do a loop instead. We're only inserting one record here, so I'm only expecting one record, and I'm just going to use the dot next here. Okay? All right. And then the result here is the new director, and so return result. There we go. And this is option B. Get the inserted key values. All right. Let's make sure that everything works. I don't think I certainly don't have that director Dennis Villanueva in here, but I don't have the film either. So let's see if all of these things work. I create this director over here before I. Oh, sorry, we never finished the film, did we? So let's come over here, right? Because this one would still fail because we're not actually getting that director record out of there, right? So let's go with director database director is equal to this function that I just created up here, get or insert director, right? And I guess I could check the director ID if this is null, then I would need to call it, right? But that'll be I could actually put that into this function to check for it anyway, right? So f.getDirector. There. So get the director directly from the database. And then I can use that database director to get their director ID. You could, of course, design this differently. You could design a method that, given a first name and a last name, there are no objects at all. Given a first name and a last name, it returns the director ID. Or here's a director object. You know, you check to see if the director ID is null. If it is, then go ahead and execute the database query and create a new director or something like that. Some databases even have, in addition to the CRUD, right, create, retrieve, update, and destroy, insert, update, delete, and select, they have yet another query that is, well, that's where I got this name, select or insert, or something like that. I don't remember what the name is, but get or insert. In other words, you can query using a select-like statement, and if that record doesn't exist with those values, then you can actually tell the database to go ahead and insert it and then give it to me, so that I'm not doing 2 queries. Does it exist? No. Okay, insert it, then get it, right? Actually, 3 queries there. But MariaDB is not one of those that supports that. Right? So insert film. Let's go ahead and see if this actually works now. Hopefully it does. Oh, good. It worked. Remember that we were just printing that out as as an error message. It actually did work because you'll see over here in the database, Dennis Villanueva is now inserted with a director ID of 4, and that new film, Dune, is inserted with the director ID 4, and coincidentally the film ID of 4. We can do the same thing with all of our objects, film objects, actor objects, director objects. Multiplied by 4 gives you a lot of methods that you're going to have to implement in order to do basic CRUD. All right. Any questions on that? All right. The basic idea is when you're designing these things, ask yourself questions like, man, it would really be nice if I had a function that inserted a director record for me or got it based on the name, right? Or in your actual project, like an address. here's an address object. I'd really like its address ID, right? Or if it doesn't exist, then insert it for me. Maybe that'll, okay, well, if it'd be really helpful if you had that thing, then give it to yourself by implementing it, right? And keeping the rest of your code pretty, pretty clean, right? Just make sure that you're always closing your connections, okay? All right, I'll go ahead and post that. But otherwise, let's see, what else did we have? Yeah, go ahead.
On the project, would it be appropriate to put most of these functions into one class, even though there'll be a ton of them? Or would you like them spread out, like one for all the things that involve address?
Yeah, I would say, at least for this project, that for the next phase, after the database is designed, you're going to want to put everything into, like, for example, if you designed your first two phases perfectly, then you will have this class that loads everything up, right? It loads up items, it loads up sales, it loads up people and their addresses, et cetera, et cetera. And elsewhere in your code, you simply use that class by, give me all the sales, and then I'm going to process them over here, right? So it's basically a one-liner. And now this big giant class that is loading from CSV files, right? You can replace that with this big giant class that is loading from your SQL database. Over here, all you have to do is change one line of code because you designed this so well, right? That's dependency inversion, basically. That if it follows the same API, that there is this get list of sales method or something like that, all you have to do is just switch out which version you're calling from the CSV files or from the database, right? That's the next phase. Now, the phase after that, we dictate that to you. So we give you a persist sales file or something like that, a save sales file or something. I forget what the name of it is, but we tell you, you have to have these functions. If you want to make your own additional functions, I'd say go ahead. Put them into that same class, or if you want to, you can spread them out or whatever, but that class has to have those methods because that's what we expect. We design the API for you, right? Okay. Closure resources, dealing with SQL exceptions, you just a catch and release. Did we talk about the, yep, avoid the star operator. Always use prepared statements, right? And I don't think we have this in here, but let's go ahead and put it, and I'll put it at the end here. Right. There we go. Come on, up, there. Always use prepared statements. I'm not even going to show you regular old statements. If we see regular statements, you will be docked big time for design in the coming phases. In general, strings can contain dangerous SQL code, right? Without sanitizing your code, you are susceptible to what's called an SQL injection. And if you want to see what something like this looks like, we on lab 7, 8, 9, 10, I think, we do an HTML injection attack. Which is kind of like an SQL injection attack, but it's with the HTML directly. Here's the idea in Lab 10 if you want to try it out. It's in the extras. What you can do is you can, like on Facebook, instead of making a Facebook post, what you can do is you can start making a Facebook post, and then if it's unsanitized, you can start inserting a bunch of HTML code and JavaScript code. And then if that persists to the database, the next time somebody looks at your Facebook account, your posts, that gets served to them as HTML and JavaScript. Right? And if you wrote JavaScript that was malicious and copied their information and sent it on somewhere else, right? Or redirected them to a website because your Facebook account, you need to update your password here, then we've stolen their credentials, right? If that's only possible if they don't sanitize their inputs. In other words, don't allow arbitrary HTML and JavaScript to be inserted in the database, or at least when it is inserted in the database, what you do is you sanitize it on the way out. So that's displayed actually like it'll end up being like a bunch of garbage code, and it'll look like you're going crazy because you posted a bunch of HTML as your post rather than rendering it as HTML. SQL injection attacks are similar. If you use string concatenation, what I can do is I can formulate a string that ends your SQL statement and then runs my own SQL statement afterwards, right? And an attacker may be able to gain access or maliciously destroy your database or something like that. And the classic example here is the xkcd Bobby Tables post. So here we go, exploits of a mom. Right? Here we go. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert? Ending the string, ending the SQL statement, drop table students, right? And then ending that statement with a comment at the end so that any trailing concatenated SQL statement gets ignored, right? What's happened here? I have ended your SQL, because you're using string concatenation. SQL statement concatenated with some value that's being read in from the internet, from some web form or something like that, and then concatenate it with the rest of the HTML statement. I've inserted something to end that HTML statement, run my own, and then ignore the rest of your statement, right? And the thing that I'm running is drop table students, right? And I've maliciously destroyed all of them. And of course, you can do this over and over again. If you don't get it right the first time, you can always do it again and describe your tables, list your tables, and then you know which tables you need to drop, right? Yes, little Bobby tables, we call them. Well, we've lost this year's students' records. I hope you're happy. And I hope you've learned to sanitize your database inputs. Right? Well, yeah, that's a good point. You should never pluralize your table names either. I don't know if there's a discussion on that or not, but certainly something to send to them if somebody hasn't already. Right? Prepared statements in Java sanitize your inputs, so that basically any SQL, special SQL code gets escaped. You know, like escaping an endline character or escaping a backslash or something like that. Never use anything else. Right? There are situations in which a statement you are almost guaranteed, there are no inputs, or the inputs that you do have are guaranteed to be safe and sanitized. Who cares? Still use a prepared statement. Why? Because if you get into the habit of using a prepared statement here and then a statement, an unprepared statement over here, and a different one over here and a different one over here, it leads to points of potential failure. Be consistent. It's just simpler to use one method to connect to your database. That's why I'm only going to show you prepared statements. Right? Just use prepared statements. No SQL injection attack is even possible at that point. Other things that you would do to save yourself or protect yourself from that would be to configure your database not to allow compound queries to be run at all. So that if somebody screwed up and didn't prepare a statement, then the SQL server still wouldn't allow them to do something like that. Right? Okay, let's see. What else? Oh, dealing with SQL exceptions. So last time we did cover this. Again, catch and release. If you want to log something, though, then you should be using, at this point, and this is worth bonus in your future phases, if you want to actually log something, then you should use a proper library to do it, and that's what I'm going to show you now. All right? So where is that thing that I said where there is no such director, load there. Cannot find director with this last name. What am I doing here? I'm outputting this to the system, the standard error output, right? Nobody's sitting there watching, right? This is me in Eclipse, right? When I do something like this, I cannot find director with -42. Nobody's sitting here at the screen watching this and saying, oh, okay, oh, that's missing data. To the keyboards, man, right? They don't do that, right? Instead, what you need to do is you need a proper logging system where you can define error messages or information or debugging messages or something like that, and the logging system takes care of it for you, okay? And the solution here, at least for Java, that I'm going to show you, is use a logging library such as log4j, right? And unfortunately, I didn't prepare this before we went, so this is going to be fun. Log4j download. Log4j2 is probably what I'll want. 1.2 or 2. Oh, it looks like I'll just go with the one that I've used before, right? Let's see, we can download the zip file here. Oh, come on, really? Wayne.edu? Is that Wayne State? I don't know, while we're waiting on that download, Wayne.edu. Wayne State, yeah. That's where I just downloaded it from. They've got a mirror there or something. So downloads, let's open that up. Oh, where was it? Log4j, log4j. Okay, there, Apache log4j. And, darn it. Lots of jar files here. Which one do we want? I don't want any of these sources. Probably just this one. This one. Okay, that's probably going to be good enough. Get rid of this. Go over to my Java object or project, and let's go ahead and bring this library. What else do we have here already? Anything? There we go. Come on. All right. Add it to my library. Hopefully this is enough. If not, then I'll let you know what else. But otherwise, build path, add to build path. Excellent. And now we can use a proper logging system. And find log. Nope. All right. I'm going to have to use find log. Nope. Nope. All right. Darn it. All right. We're just going to have to look up an example. Sorry. Log4j example. Blah, 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 blah. Don't worry about that. That's what I want. I want a, there we go. I want a, yeah, I'll do it here. I want a static logger, so I want it to belong to the class. You can make it private if you want, but yeah, I'll go ahead and make it private. And I'm going to have to bring this in. This is a, right there, I believe. Well, here, where did you bring this in? Should be that one. That might actually be version 1.0. Ah, darn it. Okay. Nope. That is version 1.0. I didn't want to delete everything. Sorry about this, but I'm showing you bonus, so you'll have to bear with me here. There we go. That's probably what it wants. Oh, come on, really? It's not accessible. It's not public. All right. What other options do I have? Java.util.like. Oh, there we go. It's the very last one. It's always in the last place you look. There we go. Get logger, and then this class. This is a logger for this class. Load data. Dot class. Right, get name. Get logger. Oh, really? All right. What? Dot. Nope. All right. Anyway, we'll go ahead and leave it like that for now, and I'll post later from some archives here on how to actually instantiate it. But down here, the idea is instead of using system.error.println, you would use your logger. Right? So log dot. Now, there are lots of options here. You can log a debug message. You could log lots of debug ways of an error message. You could debug or a fatal message, which is probably the highest one. An info message, like user 529 just logged in, or a warning should be at the very end here. Trace or warning message. So there are actually like 5 levels of messages. Probably fatal is at the very top. Debug or trace is way down at the bottom. A warning, and then information, et cetera, et cetera. So what I'll do here is I'll do a warning message, because I mean, it's not a fatal error. We can't find the director with this name, so we're returning null, right? And it ends up getting logged like this. Now, again, I'm not going to be able to run this to show you what it looks like because I plain forgot how to instantiate my loggers. Let me see. Do I have an old project here that uses it? Let's find out. If I've got a log4j here, yeah, I do. I have a log4j here, so I've got a way of doing this. Ignore that stuff. Probably load data. Is there a portfolio report maybe? Nope. File data loader. There we go. Database data loader. There we go. Oh, no, I don't have it here because I'm using JPA. All right, sorry. Ignore me. I will go ahead and when I post this to GitHub, I will fix this and I'll also make a post on Piazza about it. Question here. In reference to SQL injection attacks, oh, I don't know if I'll open this link that you've sent me off screen here. Oh, there we go. Okay, that's safe. So, good luck speed cameras, and it's reading an SQL injection attack right there. I've seen programming contest teams that choose a name that's an SQL injection attack as a joke, but it is a very real way of attacking websites, and it's still very, very effective because far too many people do not sanitize their SQL code, their SQL inputs, I should say. Okay. With the last half hour here, I was hoping to go over pretty quickly, like an accelerated version of this. This basically marks the halfway point of the topics in this course. The first half is all kind of, well, it's all practical stuff, but the first half is more practical. Java, object-oriented programming, database design, culminating in multi-tier architectures. What we're going to do on Thursday, starting on Thursday, is we're going to start looking at data structures and algorithms. The more theoretical side to introduce you to the more theoretical, because really at its core, computer science is not a science, nor is it about computers. It's a branch of mathematics if you want to get pedantic about it. All right? So again, up to now, your programs have been small, maybe text-based, right? They've run locally, they're single user. You might have done some graphical user interface programming like Swing, GTK, or JavaFX, or something like that. But there's little to no interaction with other programs. That's actually not the case with the vast majority of software. Most software exists as what's called glue code. You are simply writing code to connect one system to another system. Or you're pulling in a library and another library and then gluing them together so that you're not reinventing the wheel to do this major thing over here and this major thing over here. You're just gluing them together so that the least amount of effort will give you the greatest amount of results, right? Large, well-designed applications must make use of architectural design. Which library do we use? How do we design our glue code so that we bring these things in together? When I've got multiple pieces of technology that speak in completely different languages, this one server over here is programmed in C#, and this server over there is programmed in Java. How do I bring all those things together? I've got a cluster of 50 servers, right? Because we need to scale our databases so that we can serve millions of users. One piddly, server out down in the basement of CSE is not going to cut it, right? Software design, that's software design on a larger scale. That's architectural design, right? You make extensive use of databases. It's distributed, multi-user. So you have to think about those other things, right? Now you have to start thinking about thread safety, right? And throughput and load testing, rather than just unit testing where you are given assurances that your program is correct. You need to know that your program will run when there's one user and when there's a million users, right? You need to organize those responsibilities into interactions into different tiers, right? Don't worry about that. Applications with a single tier basically are thick applications, thick clients. Installed programs like Microsoft Office. They're single user they're resource allocation problems. They're terminals with a network server. They're basically your computer. That program exists on your computer and only on your computer. Now, it might be going out and getting some data from the network or whatever, but that's in stark contrast to, say, Google Sheets or Google Docs, where you have multiple people collaborating on one document, right? Distributed, multi-user. One-tier architecture, everything is packaged into one tier. Your file server, your database server, your presentation, something called the presentation layer, where you're actually displaying the data, etc. Two-tier architecture introduces the client-server model, where now your computer is acting as a client, a thin client. And a lot of the heavy lifting is done on the server, remotely. The client runs applications and may be responsible for the business logic or the presentation, but the persistence of data, that's stored on some separate database that may not even be on the same server. It may be halfway around the world, right? It's more secure because there's authentication, distributed, it supports concurrency, et cetera. It's just another abstraction, right? You're not doing everything in one tier. Just like you're not doing everything in one method or one class, you're separating out major responsibilities between two different tiers. There's nothing to stop you from going to 3 tiers. The database tier might manage the data at the low level. We usually call this the middle tier or the business logic layer that is responsible for the communication between the user, the presentation layer that the user sees, and the database layer down here. Like, for example, your Java code right here. The client tier is the interface between the user. And on this week's lab and next week's lab, you'll get exposure to that. We have an HTML page to manage your albums database. That's the presentation layer. It shows you in a table your list of albums. You can click on an album to get some detailed information. Behind the scenes, this middle tier, that's what you're actually implementing in JDBC. Below that, 3 tiers here. Below that, at the very bottom, is your MySQL server sitting on CSE. And the presentation layer may not necessarily be for human users. It could be for an API. That one computer is connecting to another API computer and talking back and forth using XML, JSON, or some other interchange format entirely. The separation of tiers allows for modularity on a large scale. If you've got a large enough team, if you have a large enough application, you might have a database team. You have a middle tier team. You have an iOS team that is responsible for maintaining the application on iPhone. You have an Android team. You have a desktop team, right? You could have all this separation of responsibility, and because of loose coupling, you don't have to worry about the database folks worrying about the, I don't know any Swift, I don't know any Java, I can't write an Android program, right? You don't have to. You stay in the database stuff and do what you know you're doing, right? Each tier can contain completely different technologies, and it can be completely interoperable, right? Various databases like SQL Server, Postgres, Oracle, MySQL, etc. Various middle tiers have been developed: C#, .NET, ASP, JSP. Those are Java server pages. That you'll be exposed to that in your lab this week and next. It could be Java-based, purely Java-based, PHP-based. It could be C++. It could be Perl, right? It doesn't matter because all of those things can connect to a database in some way. You might have frameworks like Ruby on Rails or Angular or whatever, right? You might have also in-betweeners. These no longer exist, though. Microsoft Silverlight only existed because of DRM in Netflix a long time ago. Flash, I think that even Firefox, or maybe it was Chrome, finally completely deprecated. You can't even turn it back on now. So all those Flash games that we love to play, they're all gone, right?
For some clients that try to store it, you can kind of get around it by actually going into your computer settings and changing it back before
Okay, so never upgrade your web browser. That's the key there, right? Or Java applets, which has also been deprecated. They're gone. But I would add that one in-betweener now is, dang it, now I forget what it's called. It basically packages up an entire browser along with your HTML, JavaScript code. Electron, that's it. That's what it is. Creates this huge, giant 300 megabyte executable. And now all you have to do is write everything in JavaScript, HTML, etc., and you can distribute it as a runnable program by packaging up your own browser with it, and it's huge. I think I did a Hello World program in it once, and it was like 300 megs. So it's not quite ready for prime time, in my opinion. But you know what is? What's based on Electron? Atom.io. Atom.io uses Electron, so that everything in the back end here is JavaScript. It's all written in JavaScript. A lot of you might have used Atom.io yet. No? Okay. If you'd used CS50 last semester, you might not have used Atom.io. It's a free text editor, basically. You can get crazy, even crazier if you want. You can have n-tier architectures. You can add as many layers as you want. For example, you could have a seven-layer burrito. You have a database layer. You have a data access layer using some sort of ORM like JPA or ADO. JPA is Java Persistence API, where you don't have to write your own CRUD anymore. Right? Everything that I just showed you in Jdbc, it's abstracted away, and you can simply annotate your classes and say, this class is associated with this table over here. This variable in this class is associated with this column over here. You do all the work for me. Right? Cool. And if you want to learn more about that, I have an extra lab as well as a video showing you how to do it. Otherwise, you might have then on top of that a first level business tier because you have multiple clients. So if you write banking software, right, you have multiple regional banks that you want to serve. You want them all to be your client. All banks have some common set of functionality. They all have checking accounts and savings accounts and stuff like that. And you can put that in your first tier, right, that everybody has that functionality. Then you could have a second tier where you provide client level support and customizations on top of that. Well, this bank also has this kind of product that they want to sell, so we'll go ahead and add that on top of it. But we'll keep it in this layer because that bank over there doesn't use it, so we don't want that to be common to everybody unless it, oh, hey, that's a good feature. Let's go ahead and upsell everybody on that feature, right? You could have a validation layer on top of that where data going in and out of the bottom layers is validated, that no, you cannot have a negative balance or something like that. You could have a presentation layer on top of that where you are displaying somebody's account information on a website or on an iOS phone app. Then you can have a templating layer on top of that because, again, if you have multiple clients, you don't want, Bank USA, their logo appearing on Bank XYZ, right? You want a templating layer where you can, you don't have to reinvent everything down below, right? You just reuse that over and over again, but you just create a template for them, right? We're going to change that logo. We're going to change the red theme to a blue theme, et cetera, right? If you keep that in a templating layer, then you're not messing with any of the code or any of the ideas at the lower layers. How many abstraction layers do you need? Right? What layer should be responsible for what? Do we want a thick client, a thin client, both? Do we want to support multiple platforms, et cetera, et cetera, et cetera? Do we do a web app? How do we manage data? Do we have one SQL server to rule them all? Do we cluster them? Do we hire Amazon to do all of our database for us? And we're paying them a fee. That goes back to something I kind of skipped up here, but where is it? There. Software as a service. Oops, sorry. Software as a service or platform as a service or networking as a service or infrastructure as a service. If you're a small company and you're hoping to grow, but initially you don't need 50 servers when you've only got 100 users, right? So what you can do is you can outsource that. You can rent server space from Google. You can rent it from AWS, et cetera, et cetera. You can grab entire software platforms and rent them out, so that you're using some middle tier software like SAP software from IBM or something like that. You can have platform as a sort of network, right? We don't want to pay for our own physical network T1 connections or whatever they are. Nowadays, we don't want to upgrade. We'll go ahead and just outsource that, and we'll use your big giant connection over there, and we'll just pay for a fraction of your bandwidth. Right? Infrastructure as a service is a catch-all for all of that. That's a decision that you have to make when you're on a software project. Like, are we going to have our own database, or are we going to outsource that to AWS because we're already paying a bill for it, so we might as well use it, right? What languages, what platforms, what technology or software do you use? When you're making those decisions, a whole bunch of other things have to come into play when you're architecting this stuff. Who's your user base? Are they power users or are they grandparents, right? That are not tech savvy. How many users do you want to support initially? How many do you hope to support? How many users do you need to actually pay the bills, right? Versus a startup that will run on investor money until some point at which the investor says, hey, you're worth something, I'm going to sell you off to somebody else, or you're not worth anything, no more money, and then we shut down, right? If we don't have enough users at that point. The location is also important, right? One gripe that we're always getting from, say, down in the Haymarket is that we don't have a lot of folks that know C#. And we don't really cover it in the curriculum. Maybe we should, I don't know, but you also have to think about your user base. A bigger question for them is, we're in Nebraska, right? We're not in California. We're not going to get a whole bunch of half of our students, by the way, if you don't know, when they graduate, they leave the state, at least half. Pay is also substantially higher out of state. I think that the last numbers we ran on exit interviews, you can expect about 20 to 30% higher salary going outside the state than in Nebraska. And so be open to relocating. In fact, be open to relocating often throughout your career. Because unfortunately, one reality of industry is the only way that you're going to get a raise is by switching jobs. Don't trust your employer to take care of you as far as, oh wow, you've done a lot of work this year. We're going to give you a 5% raise every year for the rest of your life, right? Don't expect that, right? If your pay remains stagnant after a couple of years, always go out and see what's out there. Always maintain your CV or your resume and be open to new opportunities. I worked with a guy many years ago that was very clear to his employer that, it's my annual check on other jobs day. And he said, well, I'm going to take a day off next Friday because I've got an interview at this other place. And there was an understanding there that I'm going to interview there to see what it's like, to see what kind of salary there is. And by the way, when I come back, I'm ready for my annual review, and I'd better see something there, right? He was completely open and forthright with his employer because he knew that at least in our industry at that time, and frankly right now to a point, that you can easily change jobs. There are economic downturns where that's not the reality, so be prepared for that as well. But in our industry, changing jobs usually can return, high, 20, 30, 40, 50% higher salary. If you want to know more, just go on to the two great websites for that. One is glassdoor.com. It'll tell, it's basically a rate my professors, but it's for companies. You can look up the company and see what people have said about the company. And another one is say, a relevant subreddit. Where you can ask CS career questions or something like that. People are all, or personal finance. People are always saying, "Gee, you know what? I really like my job, but I got an offer for another job that's $40,000 more, but it's an additional hour commute. What do you guys think?" Right? And you'll see this stuff all the time. You do have to bring that into play. I have to commute every day for a goddamn hour, right? I left a higher paying job. This is 10 years ago to come to a lower paying job, adding an hour round trip commute to my day. Why? Well, because it was a lot more flexible. You see my uniform here, right? There it was all business casual. It was worth a 20% pay cut to not have to wear a goddamn suit or a business casual every day of my life. So you have to decide what is best for yourself, what's best for your family, and all those things come into play. Right? When you're deciding about a project, then you have a budget coming in. Right? In fact, correctness, quickness, and cheapness. Choose two of them. You can never choose all three. Because if you're going to do it cheap and quick, it's probably not going to be correct. If you're going to do it correct and cheap, it's probably going to take some time. Right? If you're going to do it, what's the other combination? If you're going to do it correct and quick, it ain't going to be cheap. Right? This is referred to as the iron triangle. What is it? Where it's down here. Iron triangle of project management. Right? And it's an iron triangle because you can never you can only ever take two edges. You can never take the third. Right? You can't collapse it down into a point of project management. You have to choose two, at most two. Of course, you could choose one. We'll do it correct, but it ain't going to be quick. It ain't going to be cheap. Right? But you want to maximize those things. Right? Also, your available resources and knowledge. Right? If you're a .NET house and you want to suddenly start working with Java libraries or whatever, for whatever reason, or doing Android development and nobody knows Java, guess what? You're going to be paying for a new developer, or you're going to be paying to retrain your current developers, and that happens all the time. Professional development, part of your professional development will be going to seminars, going to code camps, and things like that. Always make sure that it's on your employer's dime. Right? Don't pay for that crap yourself. Right? Hardware, of course, is another factor. Systems also evolve, so the decisions that you make on 3 months ago may no longer be operable now today. You might need to make significant changes. That's where refactoring comes in. Additional layers may be introduced. If you had 3-tier architecture before, you might need to introduce another abstraction layer in order to scale to the millions of users that you just got, right? You might have migrations. How do you deal with that? You can't be shutting your database down for 24 hours, right? You can't be shutting it down in the middle of the day. You have to carefully manage your migrations and say, we're going to have some downtime. That means that you're coming in on Sunday at 3 a.m., right? It's just a fact of life, right? You're on call, and that's when the migration happens, because then that's the minimum amount of disruption. So be it, right? Your weekend is ruined on that one day. The introduction of new techniques or technologies may mean that, oh, hell, there's this brand new database out there. Let's go ahead and try it out, right? Because it's way faster. It also may be necessitated by market suppliers. Again, the last place that I worked at, they were still hiring RPG programs. Probably to this day, they're hiring RPG programmers. Anybody know what RPG is? No, not a role-playing game. I have no idea what it stands for, but it's a programming language. It's an old green screen programming language. COBOL, all right, COBOL programmers are still in demand to this day. Probably not as much as they were, but they've got job security because those are unicorns, right? They don't exist anymore. If you can get into a nice secure position like that, great on you, but career growth, probably not so much, right? You're trading security for a lack of growth. I'd also put Cold Fusion under that. That was a language or technology put out by Adobe. It's all but dead. Even Rails, there was a huge spike in Ruby on Rails. Oh, we've got to use this new platform. We've got to use Ruby, and the popularity kind of almost went down almost immediately. You know what's popular by looking at, say, TOEB index or GitHub indexes. People will run bots to see what's popular on GitHub right now. Right? Each one of those measures has some bias that you have to take into account. For example, the GitHub stuff, that's not looking at actual corporate repositories. Those are all going to be private, probably not even on GitHub, right? Unless they've opted into the Microsoft system. So you're getting a bias towards open source software stuff. But there are measures out there that, well, what's popular today? Usually the top 5 are invariant. C, C++, Java, PHP, C#, and JavaScript, right? You can't go wrong if you know a good subset of those. Right? You might want to learn a few more, though. Oh, wow, I want to do some iOS programming. Let's pick up some Swift, right? Good design is loose coupling, just like good design at a class level. You want to make sure that a class is a single responsibility. You want to make sure that this tier has a single responsibility, right? Whatever that means. That means something larger than just a class, but the idea is there so that you can take this tier out and replace it with something completely different, not affecting the tiers above and below it. You want interoperable standards. You don't want to write your own stuff. You don't want to roll your own. You don't want to reinvent the wheel. You want to leverage, it's much cheaper to go with AWS than it is to buy a $10,000 server and upgrade it every 2 years, right? It only costs us $5,000 a year with AWS versus this $10,000. And, it's also, I was in a meeting yesterday and I mentioned that what the other person was talking about was CYA. They were saying that the university was trying to discourage people from writing their own apps and stuff like that because, if there's a break-in, there's a security issue, then it's their fault, right? Then you're responsible. But if you use an external app and there's a break-in, then you can point the finger and, no, it's not my fault, it's their fault. And I said, well, that's CYA. That's another very nice acronym. Does anybody know what CYA stands for? And cover your ass, right? So cover your ass by making it somebody else's responsibility, right? Pass the buck. Bad design is where you have a demarcation of responsibility becoming blurred. Your database team should not be responsible for middle tier stuff. Your middle tier stuff should not be responsible for presentation layer, et cetera, et cetera. Right? There is still probably a huge trend towards, you know what, I think we're almost done today, but that's all right. This is where I'll end it. There's still a huge trend to list jobs as we want full stack developers. That's code for something. It's code for we don't want to pay the number of developers that it's actually going to require to do this stuff. So that might be a huge red flag when you're out there looking at jobs. If you see we're looking for this rock star full stack developer, that means that they're looking for somebody who can do the database stuff, the middle tier stuff, the presentation layer stuff. And by the way, you're going to build our iOS app, you're going to build our Android app, you're going to build our desktop app, you're going to build all this stuff. Yeah, exactly. No, this is like you know, a dozen people working for a year, not me, a full stack developer that you can get for 1/12 the price, right? So be careful. If you don't do it right, you have what's called technical debt, right? You are taking a loan out on your time in the future, and you pay interest on your loan. You have to find time to do it the right, or you have to find time to do it over. I'll go ahead and skip down here to software engineering. It's much more than anything that I've already talked about. There are software development methodologies. We're trying to follow kind of the agile family, where we've got sprints, 2-week sprints. You've got deliverables at the end of those sprints. And then I do the retrospectives, but in an agile team, you would have the team members doing retrospectives on each other. You have business requirements or elicitation, right? Design specifications where the business requirements are you have to go to the stakeholders and say, is it possible that somebody has 5 emails, right? Do you want to support that? Yes, no, right? That kind of requirements elicitation. That's part of the design. The requirements was given to you in that handout, but the design specifications, that's why you're maintaining that design document. You have to come up with use cases. How are people actually going to use this? Testing and quality assurance, not just unit testing, which you're somewhat familiar with JUnit and CMACA last semester for most of you, but integration testing. 2 teams come together and they need to make sure that their stuff works together. Automated testing, regression testing. Did we screw anything up? Tests that were passing before, are they failing now? Performance and load testing. All right? Just because it works on your computer with 1 person doesn't mean that it's going to work when you've got 1,000 people hitting the same server at the same time. Right? Version control. Don't use CVS. Do not use SVN anymore. Get one. All right? Another one I'd throw in there that lost is Mercurial. Don't worry about those 3 things. Get one. Make sure that you are using Git to the fullest because it is now a standard tool, right? And you will be using it out there in the wild. Build and deployment measures. There are entire teams whose job it is to do CI. That's a continuous integration. They don't write any code at all. They just write deployment scripts. And scripts that will run all the tests, run all the integration tests. They write and maintain these scripts, and that's all they do. They don't actually write any of the code. They don't actually write any of the database stuff. In fact, the place that I worked at before had 2 people on that team. All they did all day long was write deployment scripts and make sure that they worked, of course. You also have to be a little bit of a lawyer. There's a good IANAL. I am not a lawyer, right? So always preface that, just like, I am not giving you financial advice, but here you go, right? You have to come up with some legal and ethical framework for yourself. Are you violating copyright by using this library? Are you violating somebody's patents? Are you respecting the licenses of others? Are you issuing licenses that make sense for yourself? There's also privacy concerns and accountability and compliance. Sarbanes-Oxley, NIST, those are 2 major standards that you may have to adhere to at some point. And an auditor will come in and say, nope, you fail. Back to the drawing board, right? Especially with NIST. That's the National Institute of Standards and Technology, right? And by the way, paying for an auditor to come in and audit your software for those kind of standards costs tens of thousands of dollars. And if you fail, it's going to cost you tens of thousands of dollars to get recertified, right? Et cetera, et cetera. Many other issues, right? So at the end of the day, a software engineer has to be sometimes be a lawyer, a philosopher, a diplomat for teamwork, a designer, a manager, a writer, and a programmer. And I put programmer last. Why? Because at the end of the day, depending on how sophisticated you get, if you're an architect way up here, you're not writing lines of code down here, right? You are now management, right? And there are plenty of companies out there that hire engineer managers. For example, Garmin. They don't hire managers out of business school. They promote from within, and they're proud of that because they need their managers to understand the design and the engineering process. All right. Any questions? No? Okay, then that's where we'll end it. And we'll start on data structures and algorithms starting on Thursday.